So now what we want to do is in this segment continue on with inverses, but we want to be we're concerned with those other three trig functions and their inverses and how to handle problems that might crop up there. These are not used, these new ones are not used near as much as those first three that we just went through. So we have to start, and earlier in this course I have not emphasized these other three functions very much. So I want to just try to I want to go back over those kind of quickly with you. If we're looking at the cotangent function, you have to almost build, you have to think your way into what it looks like or just flat out memorize it. It looks like something like this. It's like an upside down tangent except shifted over. So here is his one cycle of a cotangent graph. And remember what the cotangent is. It relates to x over y. So if you have some angle, given to you, then your x over y is your cotangent reading. X over y. Or if you're in your unit circle or doing these functions, you can think of it as your cosine of your angle. Let's go ahead and write it that way. It's the cosine over the sine. And I should write theta here instead of x there. Okay? Right, you all know this. So here's one cycle of that graph. And there's multiple cycles. But the reason, why did I only draw one cycle? Because I want to make sure this thing is 1-to-1, passes a horizontal line test. So I don't want to draw another cycle, but I could dot it. There's an infinite number of those, aren't there? And they continue to the right and to the left, looking something like this. All right? So we'd restrict this to one cycle from, look at the angles that are restricted there. The angles are restricted from 0 to pi, not including either one. So this portion captures all the possible cotangent values in your unit circle, 0 to pi. The graph of this, inverse, when you interchange the inputs and outputs, is going to be, it's going to have vertical asymptotes at y equals 0 and y equals pi, corresponding to x equals 0 and x equals pi. The point over here on the cotangents graph, pi over 2, 0, corresponds to 0 pi over 2, a y-intercept over there. Here's something that can help you figure out the rest of that graph over here. Look at this region right in here. Between 0 and pi, that's going to become y values over there in the other graph, right? This region. These values between my fingers, finger and thumb, right? Those values are going to become the y values on the other graph. Notice that the y values here are positive on this graph. Y values are positive. So are the x values, right? So that means you're going to show up in what quadrant over here for this portion of this graph in the inverse? It's going to show up in quadrant 1. It's going to show up in quadrant 1. So let's see. If you move up on this graph, if you're increasing this ratio value, then which way are you moving on that graph? If you're moving up on this graph in y, that means you're moving out to the right in x over there, right? So if I'm moving up, look at what's happening to these x values. They're getting smaller, which means what's going to happen over there? The y values will get smaller as I move out in x. So the y values are going to get smaller as I move out in x. So you can play with this with your fingers, okay, to try to help you make these connections between the reversal of the inputs and outputs. So it's going to be coming down like this. And so the graph looks like this, approaching that horizontal asymptote. And then you should expect then that other region would be where? Look at here. If you go higher than pi over 2 in your angle, heading towards 180, right? If you're heading towards 180, the cotangent readings become negative and more negative. So over here on the inverse graph then, I'll have you guys move the camera, thank you. As the angles continue to grow from 90 towards 180, heading up this way, then you're going to be seeing negative values showing up, and you're going to get the rest of this graph heading out that way. So here is a graph of your inverse cotangent function. I don't even think I'm going to get to cosecant. I don't think we need to, because it's used so infrequently. And then by the time you get into second year calculus where you might need it, you can just, it'll come to you pretty quickly because you'll be so familiar with your fundamentals of trig. Okay? So let's just do a little bit of the secant though. And like I said, I'm not going to test you on this in this course, but later on this stuff does become useful. So if you take your secant graph now of x, then you remember that it rides on which graph? Cosine. So the way I would always do, and earlier we did transformations, and you're going to see it on the midterm, you'll see it on the final, you see it the rest of the course, okay? So the way to do these things, if you're ever asked to graph something like a secant or cosecant or cotangent when there's stretches and squeezes and all that, do the graph of the fundamental. Like in other words, spend your time drawing the cosine graph that you might have, and then with your transforms, and then apply, then take and let this graph ride on it. So what I mean by that is draw a cosine graph and then draw your secant graph on top of that. Let it ride. So this is looking pretty good here, isn't it? That portion. I like that because that's all one-to-one. And then I could go further here, couldn't I? Have a vertical asymptote here, and then I know, oh, here we go, that portion, right? And we know it continues like this and like that, but we don't want to go any further in the domain, do we? Okay, so we have a restricted domain here, and I would label these points 0, 1, and out here at 3 pi over 2, comma, negative 1. And the vertical asymptote is where? X equals pi over 2 is the vertical asymptote. Got it? Does this cover all the possible secant values? Notice the range here on the secant, just as a quick review. And then we'll be done here in about a minute or so. The range, which I don't know that I ever actually wrote that down, but you should see it. Negative infinity coming up to negative 1 inclusive, then isn't there a gap? And then you get to 1, you have to start again up here at 1, and now continue on up to infinity. So that range becomes the domain in the inverse. Okay, and so look at the angles associated with the unit circle. We'll do this real quickly. It looks like 0 to 90 degrees is looking good, including 0, up to but not including 90. And then we also have past 90 to 180, don't we? Right there. And then finally, real quick, just because we're out of time, the vertical asymptote becomes a horizontal asymptote up here at pi over 2. 0, 1 becomes 1, 0. Positive values in here have to stay positive in the first quadrant there. Looking like this, isn't it? And then we have to go higher than pi over 2. We have to head up here towards 180, don't we? To pi. We have to get out to 180. Well, actually, I'm sorry, I screwed up here, didn't I? You should have caught me. Back here. That's not 3 pi over 2. That's what? That's pi. Okay, so that point would plot as -1 and up here at pi. And so where's the rest of this graph? The y values are positive. The x values are going to be negative over there. Where is it? It approaches the same asymptote, doesn't it? Except horizontal here. Yeah, looking like that. Sound effects. Okay? There's the picture of the inverse inverse secant graph as a function of x. Okay, that was a very quick inverse cotan, inverse secant type of thing. We won't even worry about the inverse cosecant. Okay, that's it for today. Don't forget these items. Test next Tuesday up in the math lab. That's where we'll be meeting. No class here. And don't forget to bring your homework folder 6-1 to 7-1.